A January 2026 notice from China's Ministry of Commerce lists 15 companies by name, the only entities now legally authorized to export tungsten products from the country that mines roughly 80% of global supply. That list is the object on the table today. Held up to the light, it reads less like a trade restriction and more like an anatomy of a structural redesign, and the deepest layer is not a ban at all. The surface of this document looks like export policy. The interior is something more durable. A named fixed registry of 15 state-approved exporters is a circulatory system redesigned from the inside, and when you cut through its layers, the constraint becomes structural rather than episodic. The restriction is no longer in the policy document. It is in the supply chain's anatomy. We move from the metal itself outward through the supply architecture into the manufacturing nodes that cannot replace it, and finally into what the list's fixed administrative character reveals about the kind of pressure it applies. The first layer is the metal and its market position. China accounts for roughly 80% of global tungsten mine production, a figure consistent across multiple years of United States Geological Survey records and international trade body estimates. Tungsten prices reached record levels in the range of $1,125 to $1,150 per metric ton in the period surrounding the January 2026 designation per market pricing reports, though independent verification of the precise peak figure remains incomplete. Before any administrative structure can function as a choke point, the underlying commodity must be sufficiently concentrated in one geography. 80% market share is not a choke point by itself. It is the precondition. This layer establishes the raw material reality the list operates against. Moving inward, the next layer down is the approved exporter registry as legal instrument. China's Ministry of Commerce. January 2026 designation names 15 companies as the sole authorized exporters of tungsten products. This is a different legal mechanism from an export ban, a tariff, or a quota. An export ban prohibits. A registry of approved exporters administers. An approved exporter system can be maintained indefinitely, adjusted by adding or removing names, and can favor certain customer geographies over others through the commercial decisions of the listed entities, all without amending the underlying policy. The number 15 is not incidental here. It is the instrument of control. A broad licensing regime with hundreds of approved exporters is a market with paperwork. A list of 15 is a room with a guest list. That distinction determines who waits at the door and how long they wait. A ban invites legal challenge at the World Trade Organization and generates immediate diplomatic friction. A registry of approved exporters achieves similar supply effects through an administrative instrument that is, on its face, a domestic commercial licensing decision. The form of the control is part of the control. Trade data shows volume. It does not show queue depth, fulfillment priority, or which customers the 15 choose to serve first. The administrative choke point operates in that gap. The next layer down is what tungsten does inside an advanced logic node. Tungsten metallization is used in the contact plugs and interconnect barrier layers of advanced logic and memory nodes, the structures that connect transistors to the wiring above them. At nodes below roughly 10 nanometers, tungsten's resistance to electromigration, the gradual displacement of metal atoms under current load, makes it, as of current process technology, the material of record for this application. Taiwan Semiconductor and Samsung's advanced nodes both rely on tungsten deposition in this role, consistent with published teardown analyses of chips fabricated at those facilities. No independently qualified volume-ready substitute has been publicly announced for this specific application at the most advanced nodes. The metal's melting point sits at roughly 3,400 degrees Celsius, the highest of any element, and its behavior at 3 nanometer scales is precisely why the chip industry cannot substitute around it at advanced nodes. Tungsten is not chosen for cost. It is chosen because nothing else survives the conditions inside a logic gate at that scale. The teardown analyses confirm tungsten's presence in contact plugs and barrier layers, but the exact thickness and deposition method are proprietary. The manufacturer's own process documentation does not enumerate substitution candidates because there are none currently qualified at volume. The physical constraint is why the administrative constraint has leverage. If tungsten were substitutable at 3 nanometer or 2 nanometer class nodes, the registry would be a nuisance. Because the physics of the application narrow the field to one material, The registry sits at a load-bearing point in the manufacturing stack. Below that sits the United States supply gap and its character. According to United States Geological Survey records, the United States ceased commercial tungsten mining operations by 2015 and has not resumed them at any meaningful scale. Tungsten processing, reducing ore to ammonium paratungstate and then to powder or carbide, requires specialized equipment and chemistry that does not transfer from other mining operations. The gap is therefore not only in ore extraction, but in the downstream processing chain that chip-grade tungsten requires. That 11-year absence is not a policy failure awaiting correction. It is a market exit that took infrastructure, skilled workforce, and qualified ore processing with it. Analyst estimates for rebuilding United States tungsten processing capacity vary widely, and none have been independently validated against actual project timelines. What is established is the absence of current capacity, not the duration required to restore it. Reentry timelines measured in years are structural, not political. A commodity with an 11-year domestic production gap and a concentrated foreign supply base has no short-cycle response available when that supply base reorganizes its export architecture. The deepest cut is the fixed list as durable architecture. The structural difference between a temporary export restriction and a named entity registry is durability and granularity. A ban has an end date or a condition of removal. A registry of 15 approved exporters has neither. It persists until names are added or removed, and the commercial decisions of those 15 entities, which customers to serve, at what lead time, at what price, become the operational surface of the policy. The record tungsten price levels noted at the time of the designation are consistent with a market pricing and administrative friction, though no independent analysis has yet disentangled registry effects from broader commodity market movements. The 15-name list does not restrict trade in the way a prohibition does. It restructures the commercial relationship between Chinese tungsten supply and foreign chip manufacturers into one mediated by a small, state-favored group of entities whose commercial behavior is legible to and influenceable by the designating authority. The constraint is now architectural. Consider a water main that serves an entire district. A valve that closes the main is a ban, dramatic, visible, and eventually a target for repair or rerouting. What the January 2026 registry constructs is closer to replacing the district's single main with 15 individually metered service lines, each owned by a company that answers to the same authority. The water still flows. The architecture of who controls the flow has changed entirely. The 15 names on the Ministry of Commerce list fit on a single page. That page is less than 400 words long. It is the instrument by which 80% of global tungsten supply acquired an administrative gateway. The dissection has limits the object itself does not resolve. The commercial behavior of the 15 approved exporters has not yet produced a public data set of fulfillment rates, customer geography served, or lead time changes that would allow independent measurement of the registry's actual supply effect versus the pre-designation baseline. The record price levels noted around the designation are consistent with administrative friction, but tungsten prices respond to multiple variables, including energy cost in processing, downstream demand from tooling and defense-adjacent industries, and general metals market cycles, and no published analysis has cleanly attributed the price movement to the registry specifically. What can be stated from established fact is the structure. The legal instrument exists, the 15 names are fixed as of the designation, and the upstream supply concentration is documented over multiple years of geological survey data. What the dissection cannot settle is the magnitude of the operational effect versus the structural one, whether the 15-name list has yet produced meaningful supply disruption at chip fabricators, or whether its primary effect to this point has been to price in the possibility of such disruption. The sample shows the anatomy clearly. It does not yet show the pathology in progress. Taken together, the layers of this object describe a transformation that did not require a new technology, a new material, or a new law, only a redesign of the administrative surface through which an existing concentration of supply is accessed. The constraint that Taiwan Semiconductor and Samsung face is not new in its origin. It has been accumulating in China's market share for decades. What the January 2026 registry did was give that concentration an architecture. The restriction is now inside the supply chain structure, not outside it as an external imposition. Cut deep enough into the list, And what you find is that the physics of tungsten, the gap in United States production, and the commercial logic of advanced node manufacturing were all already there, waiting for someone to build a door around them. The 15 names were not the beginning of a choke point, they were the moment it acquired a lock. What is the next object you want to place on the table? There are other materials, other lists, other layers waiting to be opened. Name one in the comments and we will see what the next incision reveals. If this kind of dissection is useful to you, subscribe, and the next cut is already being prepared.